There's a lot to explain right here. On this first problem, we found the critical values anywhere where the derivative equals 0 or where it's undefined. I found 2 points. So then I actually found the y coordinates at those 2 points. I plugged in these x values that are known as the critical values into the function and found the y values. Then I tested the endpoints. I'm going from -2 to 3. So I plugged in an x coordinate of -2 and an x coordinate of 3. Whichever point up here gives me the largest value, that is the maximum or the absolute maximum. Whichever gives me the smallest value, that is your absolute minimum on that interval from -2 to 3. We're going to try this process again. Over here on the sine graph, we looked at it in just a certain area, and we found the derivative. Now, there were 2 points where the derivative was 0. I wonder if you can guess where. And now all we need to do is find out what are the values at the critical points and the endpoints. Find the y coordinates, also known as the function values. I apologize if those are hard to see, but I plugged in the values and I found out that the very lowest point is -1. The very highest point is +1, thereby making one of them the minimum and one of them the maximum. Notice these graphs are pretty easy to figure out if you can see what they look like. A sine or cosine graph wouldn't be hard to find the mins or max. But what if you had a different trig function or some kind of transformation and you weren't sure? You could use the equation to find those points without seeing the graph. Here, this graph looks misleading. Little did I know that 8/100ths of a point higher than 1 and -1 was the true max and min. So sometimes a graph can be misleading. It won't be down here. There was only one critical value, and that's where it is undefined. So when we look at the y coordinates of that critical value and the endpoints, you can see clearly where the highest and lowest point are. Not that you couldn't see them clearly on the graph. But some people, without having that graphed for them, wouldn't be able to identify what this looks like. So this is a good way, with just an equation, to figure it out. And finally, for our last problem, we're looking at the critical values, and there are none. The slope is -1/2 everywhere. That means the max and minimum must be the endpoints. Those are the extreme values. So the newest thing that we learned, besides a ton of vocabulary, was what's the critical value, and they're super duper important. It's where the derivative 0 or undefined. Don't forget to check the endpoints. Just because they weren't important when we looked at the entire graph doesn't mean that they might not be important if we're looking at an interval. That, my friends, is 3.1, how to find extreme values on an interval. Thank you.